Okay, now we're going to try the least squares method. Okay, so the least squares method. Through this method, you're going to get to the same answer, but it's a slightly different method. I would say this method is kind of a preview for other methods that there's a lot of very rich mathematics out there involving this kind of stuff. And it draws a link between calculus and linear algebra. The other thing that is good about the least squares method is in the last method, we got the line of best fit. Yeah? Fine. But with the least squares method, it'll find you the line of best fit, but it'll also tell you the distance between that line and each of the individual points. So that's an advantage of it. Okay? And so when I say I'm going to minimize ax minus b squared, okay? I'm going to call this a, I'm going to call this x, and I'm going to call this b. Okay? So I'm going to write this in a slightly different way. Let's say ax and b. Okay. This guy would be m plus b, 0 plus b, and 2m plus b. Oh, sorry. Okay, so all I'm doing is having a act upon x. Right? Okay, so that means that ax minus b m plus b minus 1, and then, well, that would be just b. And this bottom one would be 2m plus b. Now, okay, so we have ax minus b. So what are we going to do is we're going to minimize the square of the magnitude of this thing. So the magnitude of m plus b minus 1, b, and then 2m plus b. Close that off. Okay. And then square. Okay. So remember that whenever we were talking magnitude involving vectors, it's the sum, it's the square root of the sum of the squares, okay? So, I mean, you can think of it as Pythagorean theorem, just in higher order. So, it's the square root of like a squared plus b squared plus c squared. So, but when we square it, we're getting rid of the square root. So, this thing is going to equal m plus b minus 1 squared plus b squared, and then plus 2m plus b squared. Okay? And we will call that LS. for least squares. Okay. Okay. Now you have a function of two variables. All right. So what we're going to do is we're going to take partial derivatives of this thing. So the partial derivative of the least squares with respect to m, that's going to be, well, now 2 it's b, and then multiplied by 2 by the chain rule, because we have to take the root of that 2m on the inside. Okay? Now, we're going to take the partial derivative of the least squares method with respect to b. Okay? We'll get that guy right there. That will equal now 2 m plus b minus 1, and then plus 2b, and then plus 2m plus b. Okay? And we're going to take both of these and set them equal to 0. Because remember, whenever you're looking to minimize something, to find a minimal point, you take its derivative and set it equal to 0. That's how you find critical points using calculus. So we're going to take both of those partial derivatives and we're going to set them equal to 0, and it's going to form a matrix. Okay? Okay, so now let's look at, all right, how many b's would I have on this one right here? So I'd have a 2b from that portion, and then 2 times 2 is 4. All right, so that would be 4b plus 2b, which would be 6b. Okay. Now you have to consider, so we'll look at that one right there. Okay, so then we look at, I mean, it doesn't matter which order you do this in. All right, now we're looking at the m's. So the m on the opposite side, well, that's 2m times 4, that's going to be 8m. And then we have a 2m right there, that's going to be a 10m. Okay. And then we have to consider what constants exist inside of here. And then we have a negative 2. And we're going to set that equal to 0. Okay? Great. And so then we're going to say, okay, that's from the partial derivative with respect to m. Now we look at the partial derivative with respect to b. So let's look at the b's first. We got a 2b from this one, a 2b from that one, and a 2b from the other one. So that's 6b. Okay, now we have to consider how many m's we have. Okay. All right, 2 times 2m, that's going to give us a 4m. And then 2 times m is just another 2m, so that's going to be 6m. Okay. So this is going to give us a system of equations that we're going to solve to find b and m. Okay. So let's just move those 2's to the opposite side of the problem, and then we'll set it up in matrix form. So 6b plus 10m equals 2. And 6b plus 6m also equals 2. Okay. All right, now let's write this down as an augmented matrix, and let's solve for what m and b are. And granted, we've already done it for the other method, but let's do it for this method as well. So we have 6, 10, 6, another 6, augmented with a 2 and a 2. All right, so we take the top row, multiply by -1 and add. That's going to give me 6, 10, that would be 0, that would be a -4, that would be a 2, and that would be a 0. Yeah, let's just divide by -4. 6, 10, 0, 1, 2, 0. Okay, then we can multiply by -10, add upwards. Okay, that's going to get me, it's not going to affect anything, 6, 0, 0, 1, 0, 2. Then I can divide by 6. 1, 0, 0, 1, augment, 0, 1/3. Okay, now but remember, when I set up this problem, I set it up in a slightly different way than I'd set up the previous problem. I set it up as 6b plus 10m, so b is really the first one. So what is that telling me? It's telling me that m equals 0 and b equals 1/3. So y just equals 1/3.